Hi students, the first numerical problem in atomic and nuclear physics. Two hydrogen atoms HA and HB are in ground state. HA is at rest and HB makes head-on collision with HA. After collision, both HA and HB move together. What is the minimum kinetic energy of HB such that any one of the hydrogen atoms reaches the first excited state? Very simple numerical problem. Understanding is very much required here. Now we have studied that when the hydrogen atom is at the ground state, it will have the minimum energy of minus 13.6 electron volt. Suppose if it is excited to n is equal to 2, that is the first excited state, we have to supply some energy equal to 10.2 electron volt. Now in this problem, initially both the hydrogen atoms are at rest. Okay. Now the second hydrogen atom, namely HB, is moving towards A with some speed, so that it hits with the A. You can look at this diagram. This is HA, which is at rest. Its initial velocity U1 is equal to 0, and HB is going to exert a collision with A, so that let us take the initial velocity of hydrogen B is equal to U2. Now after collision they stick together. It is a plastic collision, and the combined velocity, both of them are going together with a combined velocity V. Therefore final velocity after collision V1 and V2 both are equal, that is equal to V. Already both are hydrogen atoms, therefore M1 is equal to M2 is equal to what? M, is it not? Here I can also write mass of A is equal to mass of B, which is also equal to M. Common symbol I am going to use. So first let us take the conservation of momentum. So the initial momentum, total initial momentum before collision is equal to what? M into U1 plus M into U2. So this is equal to, first one is 0. So this is a 0 plus M into U2. So this is equal to what? MU2. And now after collision, the momentum, final momentum after collision is mass is M plus M, okay, combined mass, into common velocity is V. So that this is equal to what? 2M into common velocity V. So from the conservation of momentum, P initial must be equal to what? P final. Okay, therefore from this I can express the final velocity V in terms of the initial velocity U2. So I can equate these two, so that P initial is equal to P final. So I can write this M into U2 is equal to 2M into V, so that mass can be cancelled, so that U2 is equal to 2V, or V is equal to U2 divided by 2. So this is the first equation required for us. So first we have arrived at the relationship between the final velocity V and the initial velocity of hydrogen B. So this is U2 divided by 2. So this is based on the law of conservation of momentum. Now in this head-on collision, we are going to apply the conservation of kinetic energy before and after. So now the kinetic energy before collision, total kinetic energy before collision is equal to half M1 U1 square, that is 0, okay, half into M into U1 square plus half into M into U2 square. So this is 0 plus half M U2 square. So this is the kinetic energy before collision. Now kinetic energy after collision. So this is kinetic energy after collision is M1 plus M2 is what? 2M. Okay, M1 plus M2 is 2M into V square by 2. Okay, so this is a half into total mass into V square. This is now equal to what? M into V square. Okay. Now the difference in kinetic energy can be taken as delta E. So delta E is equal to the change in kinetic energy. Before collision, it's having a higher kinetic energy. After collision, the energy is lesser. Kinetic energy is lost. So I will take the change in kinetic energy is equal to initial kinetic energy, that is half m into u2 square minus mv square. So mv square. Now for v, I am going to represent in terms of u2. So this is first term is half m u2 square minus m into u2 by 2 whole square. So this is u2 square divided by 4. Okay. Now if I take the LCM, now this is therefore delta kinetic energy. So the change in kinetic energy you have half mv square minus 1 by 4 mu square. Okay. So this is half m u2 square minus 1 by 4 m u2 square. So half minus 1/4 is 1 by 4. So this is equal to 1 by 4 m u2 square. So this is now equal to 1 by 2 into half m u2 square. So purposely I am expressing this because the change in kinetic energy is what? 1/2 of the initial kinetic energy of Hb. So I can write therefore the change in kinetic energy is equal to 1 by 2 times the initial kinetic energy. This is what asked in the question. What is the minimum kinetic energy of Hb? That is equal to what? KEI, because HA is at rest. So what is the minimum kinetic energy of Hb means we have to find the value of KE initial such that any one of the atoms reaches the first excited state. Now we have already studied so the ground state. So ground state n is equal to 1, first excited state is n is equal to 2, and here E1 is equal to minus 13.6 electron volt and E2 is equal to minus 3.4 electron volt. We have already drawn the energy level diagrams. Suppose if you want to shift the hydrogen atom from the ground state to the first excited state, then the difference in energy we have to supply. Is it not? So this difference in kinetic energy must be equal to E2 minus E1. Okay. So E2 minus E1. So this change in kinetic energy must be also equal to what? E2 minus E1. So this is equal to 3.4 minus of minus 13.6. So this is equal to 10.2 electron volt. Okay, so any one of the hydrogen atoms should be shifted to the first excited state. How much energy we have to supply is what? 10.2 electron volt. And that is also equal to what? Half times the initial kinetic energy of a Hb. Therefore, I am going to equate these two. Okay. Therefore, half into kinetic energy initial, that is equal to 10.2 electron volt. Therefore, kinetic energy KEI is equal to 2 into 10.2 eV. Okay, or the minimum kinetic energy of Hb is equal to 10.2 into 2 is 20.4 electron volt. So this is the required answer. Now, though the problem appears to be very simple, but application is there, is it not? What are all the ideas required to be applied here? Conservation of momentum in any collision, whether it is elastic collision or inelastic collision, means the quantity which is definitely conserved is momentum. But kinetic energy need not be conserved in all types of collisions. Here energy is lost because it is a plastic collision. Is it not? In plastic collision only the two colliding bodies will stick together. So it is a clear indication that there is a loss of kinetic energy. So that difference in kinetic energy we have calculated, isn't it? So this much energy only is required to shift the hydrogen atom from the ground state to the excited state. So from that we have now arrived at the minimum kinetic energy of Hb, okay, because Hb only is moving, Ha is at rest. So Ke initial must be equal to what? The minimum kinetic energy of the hydrogen atom B, okay, and that is equal to 2 into 10.2, that is equal to 20.4 electron volt. This is the answer. I hope you must have understood well. Fine.